Hello, today we'll perform the experiment of single phase half wave control rectifier using Matlab simulink. So for that what you will have to do is first open Matlab, then in Matlab once you open that there will be icon simulink. So go tick there, the simulink window library browser will open. So in this first what we will have to do is we'll have to take components that are needed in this circuit. So first for that we'll have to go to simscape. There on the left hand side there is simscape. So you open that. In that you will have to go to the sim power system, and in sim power system there is one application that is power electronics. So from this you will have to take this thyristor. Thyristor is one of the important component for this experiment. So for that, if you want to take this component, add a new model. Okay, add a new model. So one new window will open. So you will have that thyristor has come in this window. Okay, in this new model. Now for this experiment we'll need some other component. So some elements that will require, you can take it from this. In sim power system there are different elements. So we'll need a load. We'll take series RLC branch, double click on that. Okay, so you can just drag it to our model RLC circuit. First we'll take all the components and then we'll do whatever things we want to do using simulink. So next is what is needed is the AC power. So for that we'll go to electrical sources. So there is a AC voltage source here. So take that AC voltage source. We'll change its values after we'll take into the our model. So there is a AC voltage source. What next we need is we'll need the meters. So for that we'll have to go to the measurements. So go to measurements. For current measurement we'll take a ammeter, and for voltage measurement we'll take voltmeter. Okay, so before going into the details of this, first what we'll do is we'll just save this model, otherwise we won't be able to use it afterwards. So we'll have to save it. So save as. So I will save it in D drive. In D drive I have one folder that is power electronics. So I will save it there in power electronics, and there is a folder Matlab. So there I will give the name HWR half wave rectifier 1. Okay, and save. So that is saved. So whenever afterwards you want to open it, you can easily search for this HWR1 and you can modify or you can run it. Then one more thing that we require is if it is a SCR, there should be gate triggering, and for that we'll need a pulse generator. So go to simulink main window. There are sources. So from those sources take this pulse generator. Okay, and drag it here. Similarly, to observe the waveform we'll need oscilloscope. So go to commonly used board blocks, and in that there is scope, so take it never. So we have taken all the components that we need for this experiment. Now we'll arrange these components properly. We'll take this scope on the right hand side, voltmeter here, then current measurement, it will be in series with this thyristor, okay, and there will be pulse generator. So first we will modify this AC voltage source. Our AC voltage source, it is generally 230 volts, so we will make it 230 volt. And what is the frequency? Frequency is 50 hertz. Okay, so that is okay. Then thyristor, whatever the components are, we will keep it as it is. Then in this series RLC branch, we will take only resistor first, performance with the resistive load. Okay. Then now as we have to keep this component vertically, what we do is, I will do select that component and control R. So it is now placed vertically. There is a current measurement which should be in series with this, and this load will be here, voltmeter will shift slightly. So now regarding the value of this resistor, resistance value will take as 10 ohms. Okay. Then we have this pulse generator. In this pulse generator, amplitude will keep as 1 volt. Then time period will need here in the terms of seconds. So 50 hertz, you will have to give pulses at the rate of 50 hertz. So 50 hertz means 20 milliseconds. 20 milliseconds is 0.02 seconds, and pulse width will take 5%, and phase delay total 20 out of 20 milliseconds, that is for 360 degrees. So if you want to take a pulse delay of 45 degrees, it should be divided by 8, so that comes out to be 0.0025. okay, so there that will be a pulse delay of 45 degrees. So okay, so that is pulse generator. Then on the oscilloscope, what we need is, we need the waveforms of this pulse generator, then voltage and current. So we'll select the scope. On the scope, just tap here, you will get number of axes. So take 3 axes. Then time range, we'll slightly change it, we will make it 0.2. Other things we'll keep it as it is. Okay, so now you have oscilloscope with for measurement of 3 components. Okay, 3 channels you will get. So that is the defining of, will slightly increase its size so that you can easily connect the things here. Now we'll make the connections. Okay, so for making these connections, what you will have to do is, just there will be a plus sign coming here when you come to this connection. Go on connecting it to the thyristor. Okay, so that is one connection. This is second connection. This arrow type connection So oscilloscope we have defined. Now pulse generator also we have defined. We have taken the series RLC. Now we will have to do the connections. So for that I will just click it here and make the connection. This AC voltage source is connected to the thyristor. Okay. Then the second terminal of thyristor is connected to ammeter, and the ammeter second connection is connected to this load. Okay. So that is the connections. You can just check it by shifting it slightly whether it is properly connected or not. So it is connected. Now the second terminal of this resistor will connect it back to the AC source. Okay. So that completes our circuit. Now we'll have to connect all these measuring devices. Ammeter we have already connected, but this pulse generator we will have to give to the gate of this thyristor. So this I am connecting it here. Okay. Then we will have to connect this current output is here, that will take to one of the channels. Second channel we will take it. इसको थोड़ा बड़ा कर सकते हैं अपन. Then this pulse also will have to connect it to pulse. Take it here. We take pulse and then connect it here. Then the third channel of oscilloscope is connected to voltmeter. This voltmeter will shift slightly. We'll slightly shift it so that we can connect it properly. So this I am connecting it to the third terminal of this third channel of the oscilloscope. And this voltage कहाँ से measure करना है? Where we will have to measure? Across the load. So this will connect to this load. And second terminal will connect it. Take from here. Okay. So that's the way the circuit connections are made. Now our next step, now whenever we want to do this experiment, we will have to import a power GUI here. So for that what we'll do is we'll go in the main simulink library browser and there we'll search for power GUI. Okay. We'll take, so that you will have to again bring it to this model and you will have to place it here. When you use this, then only all these connections will be properly made and you will get the simulation. So this is one of the essential step here. Now I will start the simulation. So for how much time you want this simulation, that you also you can select. If I want it for, now that our circuit is ready, we'll start the simulation. For that we'll keep the time here as 0.2 seconds. You can take any time, 0.2, 3, 4 or but it will take that much time for the simulation. So we will start the simulation, and now observe the waveforms on the oscilloscope. So you can easily see here that when these are the triggering pulses, this is the voltage output and this is current output. Voltage output that is going up to 230 degrees. Then current, as resistance is 10 ohms, it is 230 divided by 10, around 23 amperes of current. Okay. So whenever you are giving the triggering pulse, the voltage suddenly rises, and then it will come to the zero state at the end of the cycle. Again, in the second cycle, when you give the pulse, there will be rise in the voltage and accordingly rise in the current. Okay. So that is for the resistive load. Now we will see half wave rectifier, this for the inductive load. For that, what you will have to do is, now we will add one more component here, resistance. We will increase this branch slightly, then we will add one more component from the library. For that, you will have to go to simulink library, then in that you will have to go to elements, or you can directly click on that icon. This is one way, or second way is click on that icon, open that component by double clicking, and branch type you can now take it as RL. This way also you can do. So inductance I will take as 10 millihenry, that means 0.01 Henry. So that is the, so we have taken R in series with L. So this is the new branch that we have introduced here. So now again we will go for the simulink simulation. So start simulation. So the simulation will start. Now see the difference in the previous waveform and this waveform. So as the inductor has the property of storing the charge, after the half cycle the voltage will not go to 0, but it will go in the negative direction, and at the same time, because of this RL circuit, see the current will start flowing, and it will start from whenever the thyristor is triggered, but it will go up to the point when this voltage comes to 0. So that is the difference with the R load and RL load. So you can easily label this is this as the triggering access properties. You can take it as pulse. Okay. So that will appear here. Here voltage is already there. Here we can label it as access properties as current. Okay. So this is the way you can perform this experiment. Here it is going more than 50, so you can change the access properties, minus 50 in place of minus 50 you can take minus 150, or you can make it minus 100 to plus 250. So that is, so you can see the waveform properly. So this is for the RL load. Okay. So this you can draw in your journal. Draw the waveforms properly, observe this properly, and draw them in your journal. Okay. So we'll stop here. Thank you for watching.